Hello everyone. We will be continuing with our BVLSI lectures. This is lecture number 43. And today's date is I think 10/4/2024. Alright, so we have last time started with the CMOS inverter. We'll continue our discussion on the CMOS inverter. So it consists of a PMOS above, and below it you have a NMOS. Both their gate terminals are tied together and given to the input Vin. Both their drain terminals are tied together and given to the output. Source terminal of both of them, PMOS is connected to VDD, NMOS is connected to the ground. So this is source, drain, source, and these are the gate terminals. Alright. Now normally NMOS is connected down. Normally we connect a capacitive load at the output. Okay. So this is your capacitive load capacitor. Normally NMOS is famous for discharging. It is a good transmitter of logic 0. And PMOS is used for charging. It is a good transmitter of logic 1. So when the input is a pulse over here, a long input 0, and then it goes directly instantly from 0 to 1. This is 0 to VDD. What will be the response of the output? How will the output respond? This is input. Will it go instantly? So it will start with VDD up till here, and it will take some finite time. That RC delay is there, because when the PMOS is on, there will be some on-state resistance of the PMOS. So due to that, there will be some delay, and then it will go down to 0. So this is V out. So when the input is logic 0, output is logic 1, and when the output is logic 1, input is logic 1, then output is logic 0. This is how it will operate. Yes or no? And then suddenly if this becomes 1 to 0, then what will happen over here? Again, it will take some finite time to reach the logic 1 level. Okay, so these delays are called as propagation delays. So basically we can say this NMOS is active low switch. It's acting as an active low switch. And this PMOS is acting as a active high switch. Meaning what? Let me draw it over here. So you have a load, you have VDD. This is V out, this is V in. Let me draw it one more time. I'll explain why I am doing that. So you have a capacitive load, V out, V in. So let's say in steady state. In steady state, my input is logic 0. What should be the output? Logic 1. So for that, which transistor will be on? This active low. So this transistor will be on, this will be off. Off means it will behave as a open switch. So my output CL will charge towards VDD level. So here for 0 input, my output will be charging towards VDD. So this transistor will be on, PMOS will be on when the input is logic 0. When the input is logic 1, now let's say my input is logic 1. What will happen? Which transistor will be on? My NMOS will be on and PMOS will be off. Alright. So this will become off and this is on. So what will happen? Whatever the charges stored at the output, that is VDD, will be discharged via this NMOS transistor. So my output will slowly go towards 0. That's why it's not instantly going, because there is a RC delay associated with it. Whenever NMOS or PMOS is on, there is a R on time, R on internal resistance associated. and the tau and the capacitor is this CL. So this is your RC delay. Because of this RC delay, the change just happened. The changes from input from 0 to VDD or VDD to 0 doesn't happen instantaneously. It takes some finite charging and discharging time. Understood? Now, so this is our logic gate, which is our inverter. Why it is called as a complementary MOS transistor? It is called as a complementary MOS transistor, right? CMOS. Why? Yes, when PMOS is on, NMOS is off, and when NMOS is on, PMOS is off. That's why it's called as a complementary MOS transistor or CMOS. NMOS and PMOS are complementary switches, basically. That's why it's called as a complementary MOS transistor or CMOS transistor. Now, tell me here what direction the current will be of NMOS and PMOS. I'm marking the current direction in purple. NMOS, it will be like this, IDN, correct? What about PMOS? Down? Upwards, yes. So it is IDP. And in steady state, both the currents should be same. Yes or no? At all times. Then only there will be a current from VDD to the ground. So always write down point number 1. Current always flows from supply to ground. So there is a constraint which is put on the circuit. What is the constraint? For this to happen, your IDN should be equal to minus of IDP. Agree? At all times. So this should hold, or this will hold for all time. Okay? Of course, in literature they write it as like this, IDN is mod of IDP. So the magnitude are same, but direction is different. Okay, so this is one of the constraints. Now tell me the other constraints. What is, yesterday we discussed about this, in a CMOS inverter, what is my, for NMOS and PMOS, what is VGS for NMOS? V in. What is VDS for NMOS? V out. Yesterday we have written it. What is VGS for PMOS? V in minus VDD. What is VDS for PMOS? V out minus VDD. So these are the remaining 4 constraints. Write them down. Correct? What?
Why should IDN be equal to minus IDP? Like why?
Y means what? Under steady state, if you want the current to flow from VDD to the ground, let's say both the transistors are switching together, then how will the current flow? One current will flow up, one current will flow down. No, that doesn't happen. So for that to happen, it's easier to show both the directions same, right? So or else you show modulus. ये वाला सही है? Or you show modulus, that will be down. I know it's really, as you said, na charging to ऊपर हो रहा है ना, so current will go up and here it will go down. But when both are temporarily on, in transient analysis we'll see this is holds. So this is one of the constraint, मैंने बोला constraint. This is not a convention, it's a constraint. So this will hold true for the entirety of time. Now why these two should be equal? For them to operate as complementary. हम लोग क्या बोल रहे हैं? Not one of them is on, one other is off. We are assuming that. तो उसका constraint is this.
So basically we want for the charging and discharging to happen in equal amount of time.
Yes.
So but एक और दूसरा offer then how will this constraint work?
This is what is happening na. Input is 0, output is 1. And input is 1, output is 0. That is what is all happening over here. That's it. We don't want anything else from this. Yeah, other will be 0. That is what we will see now. How will it happen? Magnitude wise it will try to adjust itself. This is the primary condition which should happen. You are saying ki 1 is 0, current through 1 is 0, others should be also be 0, that's true. अगर ये थोड़ा सा फ्लो हो रहा है तो ये भी थोड़ा सा फ्लो होगा, दैट इज ऑल्सो ट्रू ना? हाँ, तो यही है, ये खाली 2 कंडीशंस में होगा, आइदर इट इज ऑन और इट इज ऑफ. ये एक वेरी स्ट्रिक्ट स्विच है, बट इट डजंट हैपन. ऑन एंड ऑफ कंडीशन खाली होता नहीं है, इट्स मोर देन दैट. ओके, अंडरस्टूड और नो? So here, that is what your question, answer to your question is. Next point, if Vin is 0, what is my VGSN according to this table? 0. As VGS is less than VTON, right? VTON is the threshold voltage for NMOS device. Yes or no? Then can I say if VGS is 0, no question the NMOS is off? NMOS is in cutoff. That means what? IDN is 0. And what does this condition implies? IDP also will be 0. Now when is IDP 0? IDP 0 when it is. So this will impose some condition on VDS of my PMOS device कि उसको adjust करना पड़ेगा the VDS voltage. It has to adjust the VDS voltage accordingly. So what should be VDS voltage? अगर ID 0 है तो VDS should be 0. अगर ID 0 तो VDS should be 0 ना, right? So VDS P should be 0. PDS P 0 मतलब क्या? VDS P 0 मतलब Vout minus VDD is 0. So what is Vout equal to? That is what inverter is doing. So V in 0, Vout is VDD. So VDS voltage will try to adjust itself of the PMOS transistor. Are you understanding? See, you're understanding that current मेरा 0 है and still my device cannot be on. It's wrong. Current मेरा 0 रह सकता है, but my device will be weakly on also in a linear region. See, characteristics में linear region भी रहता है ना. The current is very small. Still there is it's in the linear region, right? ऐसे देखो. This is linear region, right? यहाँ पे voltage is around, let's say, few millivolt, 15 millivolt. It's nothing, hardly anything. And this is few nanoampere. Let's say 10 nanoampere. Then also we say na device is in linear region. It's not cut off. Yes or no? So यहाँ पे the VDSP is 0. Then we can say Vout will be equal to VDD. Is this condition understood? Okay. Now second condition. That is the fourth point. If Vin is equal to VDD, what is VGSP? Vin minus VDD ना, तो क्या हो गया? 0 हो गया ना ये? Yes or no? Because this has to be greater than VTOP. Remember, VGSP, VTOP is a negative quantities. So this has to be more negative than 0. ये VTOP is negative. So this has to be more negative than that. Alright. So this implies IDSP is 0. अगर IDSP 0 है, IDP, sorry. So IDN should be 0. So only way IDN will be 0 when VDSN is or VDSN is 0. And what is VDSN? Vout है ना? VDSN is Vout ना? So when Vin is VDD, Vout is 0. समझ में आया? this V out will be 0, it will try to adjust itself. These conditions will happen, will try to adjust such that IDN is equal to almost minus of IDP. Alright. So based on this, we have drawn yesterday the VTC curve. So let's draw voltage transfer characteristics once again. This is V in, this is V out. So from 0 to VT ON, the device transistor is off na, ye wala region na. My NMOS is cut off. Are you yes or no? And this is still VDD. This point is VDD plus VTOP. So at VDD greater than VTOP, so from here to here, what will happen? PMOS will be off. So over here, what will happen? NMOS is off. PMOS is on, but we don't know which region it is. Huh? We will understand that. Why it is linear. Here, PMOS is cut off. Off. And NMOS is on. Will decide which region it operates. At V for V in less than VTON, what happens? V in less than, V in equal to 0 क्या होगा? NMOS is off. For V in less than VTON, what will happen?
NMOS is off and PMOS will be.
Why it is in linear? वो तो बताओ. This is VTON, this is VDD plus VTOP. Yesterday we have written these conditions, right? When is NMOS off? NMOS off, PMOS on, NMOS linear, PMOS linear. You have written that yesterday, right? हाँ, तो बताओ अभी. For V in less than VTON, my NMOS will be off, right? Assuming that the transistor is ideal and the leakage current are 0. So V out will be equal to VDD, right? So यहाँ पे क्या होगा? V out will be equal to VDD. ऐसे होगा यहाँ पे line. V out will be equal to VDD, right? After that, what will happen? PMOS will be PMOS will be linear region because VDSP is becoming 0, right? अरे बराबर ना? So output will be VDD only. क्योंकि वोल्टेज ड्रॉप नहीं है ना यहाँ पे, ये देखो ये ऑफ हो गया ना. This is VDD, this is V out, and what is relating them? बराबर है. And this is what? V in, which is 0, which is less. Let's say 0.1 या 0.5 ही रहेगा तो भी. So this is less than VTOP. Let's say here this is 1 volt. So V in is 0.5. So what will happen now? This VDSP is 0. So V out and VDD के बीच में difference ही नहीं है. V out will be equal to, yes, for a PMOS transistor. And what is the condition for that? Yesterday we have discussed. Let me show that. So yesterday we have discussed those conditions, right? Yes or no? When is the PMOS off? V in is less than VTON. When is the when is NMOS cut off? V in less than VTON, PMOS cut off, V in greater than VDD plus VTOP. हाँ, अभी हमारा VDS हमारा क्या आ रहा है? Output is becoming और VDS is becoming 0 ना? यहाँ पे देखो VDSP 0 है, तो VDSP 0 कभी चलेगा बताओ? यहाँ पे कैसे? सी VDSP 0 मतलब Vout is almost equal to VDD. So VDSP is greater than VGSP minus VTOP, right? Definitely over here. So that's why it is in the linear region. So here PMOS will be in the linear region. Understanding? Now, then what happens next? आगे क्या होता है? What will happen next? Vin increases more, na? Vin increases more, so what will happen? तो इसमें क्या था? ये हो गया लीनियर में, ये हो गया कट ऑफ में. So NMOS starts conducting now because Vin is becoming greater than VTON. So ये first step है. Second step में क्या होता है? Vin becomes greater than VTON. तो NMOS is on हो गया. PMOS will continue to remain in linear mode. So NMOS on हो गया, पर on is linear or saturation we have to determine. कैसे? उसका VDSN क्या है? VGSN minus VTON. So VGSN क्या है? This is 1 volt. और ये थोड़ा सा greater than 1 volt हुआ ना ये VGSN. Let's say यहाँ पे आए है 1.5 volt पे आए हो और ये VTON 1 volt है, ये 1.5 है, तो कितना हो गया VDSN? 0.5. और VDSN क्या है? I mean what is VGSN? 1.5. तो क्या हो गया कंडीशन मेरा? VDSN क्या है मेरा? आउटपुट ना, V आउट ना? अरे VDSN क्या है मतलब? For NMOS V out now, and what is V out now? Slightly greater than slightly less than VDD. मतलब ये रहेगा थोड़ा इधर थोड़ा. So VDS out is equal to V out, which is equal to let's say 4.8 volts. Let's say तो 4.8 क्या हुआ? Greater than this ना. So यहाँ पे VDSN is greater than VGSN minus VTON. Yes or no? So my NMOS will be in saturation. समझ में आया? And my output will fall down slightly. Okay? So ये region, this is called as A, this is called as B. तो B में क्या हो रहा है बताओ? Now in next, if you increase the further, if you increase the input further, what will happen now? Third case, what will happen? At some point, हाँ, PMOS जो linear में था, that will go in saturation. Why? PMOS will go in saturation, NMOS will also go in saturation, will remain in saturation. Because ये तो condition valid रहेगा ना? कब तक? Let's say this point, middle point is 2.5 volt. तो ये V out बन गया 2.5 volt. Okay, and VGSN क्या हो गया? 2.5 minus 1. तो 1.5 still saturation में है ना? So NMOS is in saturation. PMOS saturation में कैसे है? VDS P कितना है? V out minus VDD ना? So what is this? V out 2.5 minus VDD और ये नेगेटिव होता है ना? So what is this? What is the output? ये minus 2.5 है. मतलब VDSP is negative only. It's हाँ yes. But VSDP is 2.5. We have not written mod. It's all mod. So 2.5 volt है. So saturation, sorry. V out has fallen to what is VDSP formula? ये देखो ना VDSP. V out minus VDD. अभी V out कहाँ पे आया हम लोग बता रहे हैं. V out आया है यहाँ पे 2.5 पे. Output is 2.5 यहाँ पे let's say. And यहाँ पे V in पे 2.5 है दोनों. So this region में we are determining whether NMOS is saturation, NMOS saturation में. What about PMOS? PMOS के लिए V out should be less than V in minus VTOP. ये condition true है देखो. V out should be less than or equal to V in माइनस VTOP. V in कितना है 2.5 माइनस 1 लेस ना, so it is in saturation. Agree? हम लोग मॉड जा रहे हैं खाली, we are not considering the sign as for sure. VTOP is a negative quantity. अगर वो हुआ भी तो V out also we consider this as VDSP ना, VDS itself is negative, so don't worry about it. Consider only the magnitude. समझ में आया? So at point number C, when input has fallen down to half of that is around 2.5 and out V in is also 2.5, both the transistors are on. Now we enter into some region that is D. Output has fallen to a very low value. Actually at this point VDD plus VTOP, let's say output will go to drastically go to 0 and beyond that it will remain 0. Why? ये ऐसे क्यों होता है, ये 0 क्यों है इधर? Let's check this point. At V in greater than VDD plus VTOP, क्या होना चाहिए? My PMOS will be cut off. Why? ये देखो ना, V in greater than VDD plus VTOP, बराबर है? When V in is greater than VDD plus VTOP, my PMOS will be cut off. What about my NMOS condition? We have to find out. We have to find out. Yes or no? So at what point does the NMOS goes off? The NMOS goes off at when V in becomes greater than VDD plus VTOP. तो यहाँ पे मेरा NMOS कट ऑफ हो गया, तो ये मेरा रीजन E है, ये D रीजन है. So D रीजन में हमें क्या फाइंड आउट करना है? Let's say you're somewhere around here. Let's say you're at 4 volt. नहीं 4 volt नहीं, 3.5 है इनपुट में. Let's consider that. Okay. So now input is 3.5 and output is very low. Let's say 1.2 volt. So now for this condition we have to determine whether NMOS is in which region NMOS is operating. चलो बताओ. For which region NMOS is operating, PMOS is operating? For D. For region E क्या होगा? E V out is 0. So यहाँ पे output is 0 ना? Input is greater than this. So what about NMOS condition? NMOS के लिए क्या होगा? नहीं, NMOS के लिए V out is VDS-N. V out ना? So V out is 0. बराबर ना? So VDS-N should be less than VGS-N minus VTO-N. तो ये हमेशा लेस रहेगा ना, 0 है तो ये. So NMOS will be in linear region. ये correct है. So here NMOS is in linear region. Here both are in saturation. Sir has come. Last point, D में, this is what is happening. So D में, when we come into D, C में NMOS is in saturation, PMOS is in saturation, both. So what will happen in D when we come to D point? Let's check one by one now. Okay. So here, what about VDS-N? It's V out now. So कितना हो गया VDS-N? 1.2 and VDS-N has to be greater or less than VGS-N minus VTO-N. और ये मेरा इनपुट है ना, so ये V in है, V in कितना है 3.5 minus 1, तो ये हमेशा लेस रहेगा, बराबर ना. So what is this condition? Linear. This means NMOS is in linear region. Here point D में NMOS is in linear. What about PMOS condition? So let's take, अच्छा, what is VGSP? V in minus VDD ना. What is VDSP? V out minus VDD. VDD is 5. यहाँ पे कितना है? 3.5 minus VDD 5. ये कितना है? 1 point. We are not checking VGSP condition right now because much. यहाँ पे कितना है? 1.2 minus VDD. So VDSP. Tell me the VDSP condition. VDSP should be, तो होना क्या चाहिए? Which condition it should be? D में, हाँ? D region में क्या होना चाहिए? PMOS should be in saturation. V out should be less than or equal to V in minus VTOP, right? Should be less than or equal to V in minus VTOP. हो रहा है क्या यहाँ पे ऐसे? हाँ, बताइए ये देखो. V out is how much? 1.2 na here, and V in is 3.5, and this is 1. So less na. So that means PMOS is in according to this condition. ये देखो. Okay. So you should draw the VTC curve and mark the various regions and write it down. Write this down. All right. So next time we will derive the noise margin levels and the threshold voltage for CMOS inverter. Okay.